Okay, now let's try to solve this together. Okay, first, extract all the given information. Okay, now you can see that you have like two hot stream and two cold stream, and then given delta T min equal to 10 degrees C, and T hot pinch equal to 70, while T cold pinch is 60, and QC min equal to 120 kilowatt, while QH min equal to 960 kilowatt. Right now, let's draw the stream first. Okay. I'm going to use red color for hot stream and blue color for cold stream. Blue color for cold stream. And okay, now let's mark the pinch point. Okay, pinch point. So I'm using the black color. Okay, so pinch temperature for hot stream is 70 degrees C, and the pinch temperature for cold stream is 60 degrees C, as given here lah. Okay, and okay, write the hot stream temperature from 180 degree to 80. So here lah, 80 degrees C. So we're going to erase this. Okay, erase this. And then the second hot stream is from 130 to 40 degrees C, and cold stream number 1 is from 60 to 100. So we're going to erase this. Okay. So 60 degrees C, and the final cold stream is from 30 degrees C to 120. Okay. Okay. Now let's let's do it separately lah for the region above pinch and the region below pinch. Okay, so I'm going to redraw it. Okay, 180 to 80, and then this is the pinch temperature. The dotted line is the pinch temperature, and then this is 130 to 70, 60 to 100, and 60 to 120. So this is for the region above pinch. Okay, above pinch. And recall that for region above pinch, your CPH must be less than or greater or equal to CPC. Right now, we're going to rearrange the CP value. So for hot stream, the CP is 40 and 20, and CPC start from 80 to 36 because you need to arrange it in a descending order from high value to low value lah. Okay, so in the descending order. Now, let's write the CP value. So the CP value is 20, 40, 80, and 36. Okay, now let's calculate the delta H for each stream in megawatt. Okay, now, so the first delta H equal for this stream first, hot stream number 1, so delta H will be equal to CP dt. So this is equal to 20 times 180 minus 80 degrees C. Okay, which is equal to apa? 2000 kilowatt or 2 megawatt lah. Okay, so we write it as 2, and then repeating the same calculating procedure using the same formula. Calculate delta H for each stream. So this is 2.4, 3.2, and 2.16. So we know that this is the requirement for each stream. Okay, now we're going to start pairing the heat exchanger lah. Okay, according to the rules for above CPH must be less than or equal to CPC. Now, looking at the value, okay, now we can directly pair between these two, 40 and 80, 20 and 36, because both are less than CPC lah. Okay, so now we're going to pair now 40 with 80. So this is our first heat exchanger, 40 and 80. Okay, so what is the duty of this heat exchanger? This stream requires 3.2 and this stream requires 2.4. So we put the heat exchanger duty as 2.4 megawatt lah. Okay, now this stream is, you can take this because it's already satisfied the duty of 2.4. And then our second heat exchanger is this 20 and 36. So 20 pair with 36. Now how much to put? How much the duty that you want to put it here for heat exchanger number 2? So this stream requires 2 and this one requires 2.16. Obviously we put a smaller one. So this heat exchanger will have the capacity or heat duty of 2 megawatt. Okay. Now we can tick this stream because it's already satisfied the heat duty of 2 megawatt. Right, now leaving our this 2 stream with another heat duty lah. So 3.2 minus 2.4 is 0.8. So we're going to put a heater with a heat duty of 3.2 minus 2.4, which is equal to 0.8 megawatt. And for this stream, okay, we're also going to put a heater to satisfy the heat duty of 2.16. So now we already have 2. So 2.16 minus 2 is equal to 0.16 megawatt. Okay, now if you total up the heater duty, you will get the value equal to our QH min lah. So 0.8 plus 0.16 will be equal to 0.96 megawatt or equal to 960 kilowatt lah. If you recheck the given value for QH min, so it is equivalent lah, meaning that the design is correct lah. Okay, and finally, don't forget to calculate the temperature here, T1, as well as temperature here, T2. So in order to calculate the temperature, we use the same formula. So delta H equals Cp dt. So delta H for the first heat exchanger number 1. So this is our first heat exchanger. Okay, so this heat exchanger has a duty of 2 megawatt or 2000 kilowatt with a Cp value of, because we want to know the temperature here, so we take the Cp value of 36, 36, and T delta T is T1 minus 60. Okay, T1 minus 60 degrees C. So you get your T1 equal to 115.56 degrees C. And to get T2, we'll repeat the same procedure. So for T2, using the heat duty of this heat exchanger 2. So delta H is 2.4 or 2400 kilowatt with a Cp value of, because we want to find this, so we take Cp value of 80 times the delta T equal to T2 minus 60. So our T2 equal 90 degrees C. Now we can write, you can write it here, 90 degrees C, and you can also write the temperature here. So T1 will be equal to 115.56 degrees C. Okay, now we have done with the region above page, but if you want to check delta, you want to check delta T mean must be greater or less than 10 lah. Okay, 10 degrees. So we're going to check one by one. Okay, so for the first heat exchanger, so this is the inlet. So 180 minus 115 is greater than 10. Okay, and then 80 minus 60. Okay, so this is also greater than 10, so that's correct. And then how about heat exchanger number 2? Heat exchanger number 2, the difference in temperature between two streams is, this is 130, 130. Okay, so 130 minus 90, which is greater than 10, and then say 70 minus 60, also greater than 10 lah. So it's correct. So this is the heat exchanger network for the region above pinch. Now we're going to proceed with the region below pinch. So looking at this, you only have like two stream, one hot stream and one cold stream. So we're going to do for area below pinch. So we're going to have like two streams, okay. And don't forget to show the pinch temperature, okay. So pinch and the temperature for cold stream is for hot stream is 70, for cold stream is 60. So hot stream 70, cold stream 60. So this is from 70 to let's remove the AI. Okay, never mind. So hot stream is from 70 to 40. And this is from 30 to 60 lah. And then don't forget to write the CP requirement. So CPH for below pinch must be greater or equal to CPC. So both stream have a CP of 40 and 30. Okay, have a CP of 40 and 36. Now we're going to find delta H for each stream. So delta H for the hot stream is delta H equal 40 times 70 minus 40, which is equal to 1,200 kilowatt or equal to 1.2 megawatt. Okay, so we write is here 1.2 and 1.08. Okay, now write the CP in descending order lah. So for hot stream 40 and for cold stream is 36. So you can see that the CP for hot stream is greater than the value of CPC. So we can directly pair lah between these two. So let's start pairing. So we're going to have one heat exchanger with a duty of 1.08 megawatt. Okay, now we can take this because it's already satisfied the delta H value. So only this stream still hasn't achieved 1.2 lah. So 1.2 minus 1.08, you get 0.12. So we're going to add a cooler here, cooler with a duty of 0.12 megawatt lah, to satisfy the cooling requirement for this stream lah, with delta H of 1.2. So 1.08 plus 0.12, you get 1.2 megawatt. And okay, don't forget to find the temperature here, T3. Okay, using the same formula, delta H equal to CPDT. So delta H for this heat exchanger 3 is equal to 1080 kilowatt. And the CP, we take the CP of this stream, which is 40, because we want to find T3, so we use the CP of that stream. So 40, and delta T is 70. Okay, 70 minus T3, because 70 is the inlet of this heat exchanger for hot stream. Okay, 70, and the outlet is D3. We want to find it. So now D3 equal 40, 43. 1080 divided by 40, and then 70 minus 27. You get 43. So we're going to write the actual temperature here, which is equal to 43 degrees C lah. Okay. Okay, if you check the difference of temperature, so 70 for this heat exchanger, so 70 minus 60 is 10. Okay, is delta T min, because our delta T min equal to 10, and then the outlet of this heat exchanger in a hot stream is 43, and the inlet is 30. So 43 minus 30 is 13, which is greater than delta T min 10. So that's correct. Right. So if you look at the duty of a cooler, so you know that the duty of the cooler is equal to 120 kilowatt. If you check with the QC min, you're going to also have the same value lah, 120, meaning that your design is correct lah. Okay, if the value is not same, then you need to recheck lah. So make sure the cooling utility and the hot utility equal to the QH min and QC min given in the equation. Okay, so final step is to combine both design for above pinch and below pinch lah. Okay, so we already have this here. Now we draw back lah. Okay, and you have a heater here, and then don't forget to write the temperature. So the temperature here is 90 degrees C, and this temperature is 115. Okay, and then the duty as well, we need to label it correctly. And then this is this heat exchanger has a duty of 0.4 megawatt, and then for region below pinch, you're going to have one heat exchanger with the duty of 1.08 megawatt, and a cooler of berapa? 0.12, and the temperature here equal to 43. 0.16 megawatt. Okay, so this is our final design. This is our final design.